So the next topic that we have is conversion of PDA to CFG. In last video we saw how to convert a context-free grammar to a PDA. Now we'll see how to convert a PDA to context-free grammar. So all the transitions will be given in the questions. All these transitions of PDA will be given in the question. So do you remember the four tuple of context-free grammar? Those are V, T, P, and S. V is your non-terminal, T is your terminal, P is your protection rules, and S is your start symbol. Okay, we already know. So in order to convert the PDA to CFG, you have to find all these four tuples. Okay, so we already know the states. The states mentioned in the question are Q0 and Q1. So those two are your states. Stack symbols are Z0 and X. These two are your stack symbols. Now let's find start symbol first. Okay, start symbol is represented using yes. So start symbol, the template for writing the start symbol protection is okay, initial state. As this is the start symbol, it should be the initial state, like starting of anything, starting of a PDF. Okay, then you have stack initial. Stack initial, okay, then the set of states. So what is the initial state here? Q0. What is the stack's initial state? Initial symbol Z0. For both the states, you have to write separately. You have Q0, then for Q1. Okay, this is your start symbol. Now start symbol is over. Terminal is already given in the question. What are the terminals? 0, comma 1. These two are your terminals. So terminals is also done. Now you write your non-terminals. Non-terminals is denoted by V, capital V. Right. So, so you have two terminals. Say these two are binary numbers. Okay, you have two binary numbers and how many possible combinations that it can give? So it can give you four combinations. 0, 1, sorry, 0, 0, 0, 1, 1, 0 and 1, 1. It can give you four different combinations. And we have two stack symbols. Okay, we have two stack symbols. What are those? Z0 and X. Okay, Z0 and X. So Z0 will have four combinations and X will have four combinations. So that will give you 8 non-terminals. Okay, first we will write for Z0. Okay, first and the last symbol are the combination 0, 0. Okay, then comes your 0, 1. Okay. Then 1, 0. Then 1, 1. For the first stack symbol, middle element is your stack symbol. First we are writing for Z0. Okay, then then we will write for the second stack symbol. Same combination for X. 0, 0, 0, 1, 1, 0. Then finally 1, 1. So now give a name to all these things like A, B, C, D, E, F, G and H. Okay. So now go back to your start symbol. So there is a protection Q0, Z0 and Q0. So what is the name of that particular non-terminal? Q0, Z0, Q0. It is A. So this is A. So S tends to A and Q0, Z0, Q1. Q0, Z0, sorry, Q0, Z0, Q1. So that is B. A, so that your start symbol is S tends to A or B. Okay, now we'll move on to the production rules. After the terminals, you are going to find out the production rules. So in PDA, we have three operations, right? Push, pop, and read. Okay, so for all these three operations, you should write the production rules. So from the question, how you can identify whether that is a push or a pop operation. Okay, here are the transitions. Here, if the stack symbol is same as, like if the stack symbol before adding the input is same as the stack symbol of stack state after adding the inputs, then it is a skip or read operation. If the stack symbol before adding the input and after adding the input are same, then it is a read operation. Because in read or skip operation, we do not change the status of the stack. Okay, so this is a read operation. Then this is also a read operation. Okay, and this as well a read operation. Sorry, I have written the question wrong. Here you have another X. So this is not a read operation. Only these two are read operations. Okay. So if it is not same, if the stack status before adding the input and after adding the input are different, then that is a push operation. Okay, these two are push operation. So if you have epsilon at the end, then those are pop operations. So this is how you identify push, pop, and read. So you have two push operations, okay, two read operations, and one pop operation. You have to write protection rule for all of them. First, let's write for push. The first transition in push operation is delta of q naught, comma 1, comma z naught equal to q naught, comma x z naught. This I have written from the question itself. So the first push operation. Okay, so how will you write a protection rule for this? Okay, we have two symbols on the right side. So we have to repeat the rule twice. Okay, see the template is the initial state, okay, comma the stack symbol, initial symbol, comma q naught. Okay, initial, sorry, this is the given state, this is the initial state. Initial state in the sense the first state. You have two states, right? Q naught, comma q1. So the first state, q naught. Okay, this is the given state, the question in the question. Okay, then again you repeat this twice. This is for q naught. Then you write for q1. Q naught, comma z naught, comma q1. Okay, this is your left hand side. Tends to, okay, the template is on the right side, symbol and two tuple. Why two tuple? Because we have two symbols. That's why two tuple. So what is the input symbol here? 1. Okay, into, okay, the first symbol would be the given state on the right side. Q naught, Q naught, Q naught, Q naught, comma, okay, your first stack symbol, X, 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 X. Okay, then write Q naught, Q1 alternatively. So the first tuple is done. Thus in the second tuple, you copy paste whatever you have written here, same, that is Q naught, Q1 alternatively. So make sure you just have to remember all these steps. So here it is the given state on the right side. This one is your first stack symbol. This one is Q naught, Q1 alternatively. So in the second tuple, the first elements are Q naught, Q1 alternatively, comma, second symbol of your stack, Z naught. Okay. Then the final one is whatever you have written here, you just have to write it there. That is Q naught, Q naught, and Q1, Q1. That's all. Okay, these are the transitions of your push operation. Now you should be able to replace this with the capital letters, that is the non-terminals. Okay, the first one is Q naught, Z naught, Q naught. So what is that? A. So A tends to 1 into Q naught x Q naught. Q naught x Q naught, that is E. So that is E. Then you have Q naught, Z naught, Q naught. Q naught, Z naught, Q naught is again A. So your A production is 1, A tends to 1 EA or 1 FC. Okay. So the second one is also A. This is also A. This is F and C. Okay. So this way you write the non production rules for others as well. So this is your final production symbol of this particular push operation. Sorry, we will write the S as the first equation. Okay, first equation, second, third. Okay, now first push is done. Now move on to the second push. Second push transition. What is the second push transition? This one, right? So it's delta of Q naught comma 1 comma x equal to Q naught comma xx. So how will you write? First, it is the given state. Q naught comma stack symbol. What is the stack symbol here? X comma Q naught. So you have to, so this one is your set of states. First state in the set is the Q naught. So first I have written Q naught. For push operation, you have to repeat the rule again. This is for Q naught and we are writing again for Q1. So this is your left hand side. Now right hand side. Right hand side is symbol into 2 tuple. What is the input symbol here? 1. 1 into 2 tuple. So the first tuple, first element is the given state on the right side, Q0. Okay. Middle element is your first stack symbol, comma x, comma x, comma x. The third one is Q0, Q1 alternatively. So what is the second tuple? You copy this here, Q0, Q1 alternatively, comma your second stack symbol. Okay. Third one is whatever you have written here. Okay. You copy that there. Q0, Q0, Q1, Q1. Okay. Now you write the rename. You just rename the productions. So that will give you E tends to 1 EE or 1 FG. Okay. F tends to 1 FEF or 1 FH. So this is your equation 4 and this is your equation 5. Now the push operations are done. Move on to the read or skip. So the first read or skip you have is delta of Q0 comma 0 comma x is equal to Q1 comma x. Okay. So this is the read operation. Okay, so this only for push operation, we repeat the rule twice because we had two symbols on the right side. Now we have only one symbol. So for push operation, we just have to write once, one for Q0 and one for Q1. So that is the given state on the right side, Q0, stack symbol X and Q0. So given state Q0, X, stack symbol and Q1 tends to, the symbol here is 0. Okay, and here also only one tuple is enough because we have only one symbol on the right side. So what is the given state here? Q1. Q1. What is the stack symbol? X. And write Q0 and Q1 alternatively. Okay, that's all. Now you rename them according to the non-terminals. Okay, F tends to O and H. So this is your equation 6 and this is your equation 7. Okay, now first read operation is done. Now we will move on to the second read operation. That is delta of Q1 comma 0 comma Z naught is equal to Q naught comma Z naught. Okay, that Q1 given state is Q1, stack symbol is Z naught for Q naught. given state is Q1, stack symbol is Z0, we are writing for Q1. Tends to, the symbol, input symbol is 0, only one tuple. Okay, because we have only one symbol. Q0, comma, Z0. Q0 is the given state on the right side. Q0, comma, stack symbol. You write Q0, Q1 alternatively. Okay, second read operation. Now you rename them. C tends to 0A, D tends to 0B. Okay, 6. Sorry. So this is your 8, this is your 9th equation. Okay, now you all your read operations and push operations are done. Okay, read and push are done. Now move on to the pop. Okay, pop operation. Your first transition in pop is yes, delta of q1 comma epsilon comma z naught equal to q naught comma epsilon. Okay, this is very easy. For pop operation, you have to write only for one state. Okay, whatever state is given on the right side, only for that state you have to write the rules. That is q1 is your given state. Okay, in between it is epsilon, and here you have to write the right hand side state equal to, sorry, tends to epsilon. Okay, because the symbol here is epsilon. That's all. The template is given state on the left side, given state on left side. Okay. Sorry, this is your stack symbol. Stack symbol. Stack symbol is Z0, comma, given stack symbol. This is your given state on the right side. It tends to, what is the symbol here? Epsilon. Okay, now rename them. That is C tends to epsilon. This is your equation 10. Okay, now there is one more pop operation. uh, Delta of q1 comma 1 comma x equal to q1 comma epsilon. So how will you write it? Given state comma stack symbol is x comma given state on the right side, that is q1, equal tends to, what is the symbol here? 1. Okay, so rename this transition here is h. Okay, h. So h tends to 1. This is your equation 11. So if you combine all, like write them one by one, you will get the context-free grammar. This is how you convert your push-down automata to a context-free grammar. So there are epsilon transitions, okay, useless transitions, unit protections. There may be unit protections, okay, in this CFG, which can be removed as further reduction of the grammar. But I think it is not necessary for a 10-mark question. If it is asked in 16-mark question, then you should remove all the useless protections and unit protections. Thank you.